Hey everyone! Today we're diving deep into the JavaScript event loop. By the end of this tutorial, you'll understand how JavaScript handles asynchronous operations, why setTimeout doesn't always run exactly on time, and how the event loop keeps your applications running smoothly. So what exactly is the event loop? Let me explain the concept. The event loop is like the traffic cop of your JavaScript application. It's what makes JavaScript single-threaded but still able to handle multiple tasks at once. The key points to remember are: first, JavaScript is single-threaded, meaning it can only do one thing at a time. Second, the event loop manages all asynchronous operations. And third, it's what makes functions like setTimeout work even though they're not exact. Before we dive deeper, let's talk about the call stack. The call stack is like a to-do list for your JavaScript code. It's a LIFO structure, meaning the last function added is the first one to be completed. When a function is called, it's pushed onto the stack. When it finishes executing, it's popped off the stack. This is how JavaScript keeps track of what's currently running. Now let's talk about web APIs. These are browser-provided features that handle asynchronous operations. They include things like timers, DOM events, and HTTP requests. Web APIs run in parallel to your JavaScript code, which is why setTimeout doesn't block your main thread. When an API operation completes, it sends the callback to the callback queue. Next up is the callback queue. This is where callbacks from completed asynchronous operations are stored. It's a FIFO structure, meaning the first callback added is the first one to be processed. The important thing to remember is that callbacks only move to the call stack when it's empty. This is why setTimeout with 0 milliseconds doesn't always run immediately. There's also something called the microtask queue. This has higher priority than the regular callback queue. It's where promises and mutation observer callbacks go. The key point is that the microtask queue is processed before the callback queue, which is why promise callbacks run before setTimeout callbacks. Now let's look at some actual code. Here on your screen, you can see a basic event loop example. First, we log start. Then we set a timeout with 0 milliseconds. Next, we create a resolved promise with a then callback. Finally, we log end. The output will be start, end, promise, timeout. Let me show you another example. First, we log first. Then we set a timeout with 0 milliseconds. Next, we create a resolved promise. Finally, we log fourth. The output will be first, fourth, third, second. This demonstrates the complete execution flow of the event loop. Here's a more complex example with nested timeouts. First, we set a timeout with 0 milliseconds. Inside that callback, we log first and then set another timeout. Finally, we log start. The output will be start, first, second. This shows how nested timeouts work in the event loop. Let's look at promise chaining. First, we create a resolved promise. Then we chain two then callbacks. Inside the first callback, we log first and return another promise. Finally, we log start. The output will be start, first, second. This shows how promise chaining works in the event loop. Let's see this in a real-world example. Imagine a user clicks a button. The click handler runs first. Then any promises created in that handler resolve. Finally, any timeouts complete. This is how the event loop handles user interactions in web applications. Let's compare setTimeout and setImmediate. setTimeout runs after a specified delay and is guaranteed to run after the current call stack is empty. setImmediate runs at the end of the current event loop iteration. The main difference is that setTimeout is available in browsers while setImmediate is only in Node.js. Here's a common mistake that developers make. They create long-running operations that block the event loop. The solution is to break the work into smaller chunks using setTimeout. This allows the event loop to process other tasks while the long operation is running. Another common mistake is not handling promise rejections properly. If you don't catch errors in promises, they'll be silently ignored. Always make sure to include a catch block at the end of your promise chain to handle any potential errors. Here's a pro tip for Node.js developers. If you need a callback to run as soon as possible but after the current operation completes, use process.nextTick. This gives you higher priority than the regular callback queue but lower than the microtask queue. Another important tip is to break long-running operations into smaller chunks. By using setTimeout with 0 milliseconds, you can yield control back to the event loop between chunks. This prevents your application from becoming unresponsive. For working with promises, I recommend using async/await syntax. It makes your code much more readable and easier to understand. Async/await is essentially syntactic sugar over promises, but it can make your asynchronous code look and behave more like synchronous code. That's it for our deep dive into the JavaScript event loop. The key takeaways are: first, the event loop manages all asynchronous operations. Second, the call stack handles synchronous code. Third, web APIs handle async operations like timers and HTTP requests. And fourth, the microtask queue has higher priority than the regular callback queue. If you found this tutorial helpful, please like and subscribe for more JavaScript content.